Good morning, everybody. Good afternoon and good evening. Welcome on board to our community in Encora. My name is Asma, and I'm one of the community builders in Encora. And today I am going to host the session for you. The session is called Account Abstraction. Right? We're going to have Mr. Ravikumar today take you through the session. The technical leader Ravikumar has over 12 years of experience in the IT field, specializing in web and mobile application development. He has delivered many production grade web applications for various industry sectors. He has been skilled with multiple programming languages to develop the front end and the back end side of web applications. His journey in the world of blockchain began late in 2019. Since then, he has been actively collaborated on HLF products to build on blockchain-based applications to explore Ethereum. In this talk, we will explore the revolutionary concept of account abstraction introduced by Ethereum. So now let me remind you that you can follow us in our social media appearing on the screen. And this session is a part of the Global Development Week organized by Encora. So you can use the chat to leave comments and ask questions to the speaker. So I'm so glad to invite Mr. Ravikumar here, who's the expert with us. So Mr. Ravikumar, I hand over the mic to you and please start. Thank
Thank you.
you.
Once again, hello to everyone. So let me start my sharing my screen and introduction. Okay, so the session talks about the account abstraction and the implementation proposal of ERC-4337. So let me start by giving you some background information here. Okay. As blockchain keeps on evolving and creates a new revolution in the IT sector, I'm going to talk about one of the future roadmap of Ethereum, which creates a revolutionary by opening up many doors and eliminates the existing limitations here. So let's move on to the introduction part of the account abstractions here. So the agenda of the topic here, okay, so I'm going to cover about account abstraction and improvements for Ethereum, and then types of accounts here and their limitations here. Okay. Then we'll talk about benefits of account abstractions here and Ethereum improvement proposals of that. And we'll talk about ERC-4337 proposal and implementation of it, and then architecture, technical components, and details of it. Okay. So without further delay, let's move on to the introduction part of the account abstraction here. So what is an account abstraction here? Okay. So account abstraction, it is a method of authentication that eliminates the need for private and public keys to access accounts here. Instead of that, it relies on smart contracts to verify the account's identity here. So it gives you the ability for smart contracts to interact with accounts on the Ethereum blockchain, enabling new types of accounts and transactions on the Ethereum account side. So the technology upgrade, what we see here is that it would onboard the next billion users into the blockchain ecosystem. Sounds interesting, right? Yeah. So let me further explain you more about account abstraction improvements for the Ethereum here. So let's move on to the next slide. There are many improvements for the Ethereum. Okay, I'm going to talk about these are the very important improvements of the Ethereum. Okay. The first one is that multi-account types. So it allows the creation and utilization of various account types and expanding the possibilities for the smart contract interactions here. And next one is that enhanced efficiency. So it will be going to reduce the redundant code and gas cost associated with the smart contract interactions. And next one is that interoperability. So it will promote you seamless communication between different account types, and it enables new use cases and integrations with the different platforms for the developers as well. And next one is that flexibility. So it will give you more flexibility to build complex and versatile smart contracts and advanced features. So it will be going to open up many possibilities for advanced features and functionalities in smart contracts for the developers here. Okay. So as I said at the beginning, so account abstraction creates a creates and opens up many possibilities and eliminates the current limitations here. So before going to talk about more on the account abstraction, I would like to talk about types of Ethereum accounts and their limitations for the benefit of the topic here. So let's move on to the next slide. Ethereum accounts. So types of accounts here. So basically, it has two types of accounts in the Ethereum side. The first one is called as externally owned account, and the second one is called as a contract account. So let me explain you one by one with the differences as well. So externally owned account. So it can be controlled with the private keys and interacts with contract accounts to perform transactions here. And it can also be controlled by anyone who holds the private keys here. And it costs nothing while creating an account here. And it can initiate the transactions on the Ethereum side. And the transactions between externally owned accounts can only be ETH or token transfers. And it is made up of a cryptographic pair of keys, public and private keys associated with the externally owned accounts. So next one is the contract account. So it is controlled by the code deployed on the network side. It has a cost while creating a contract because we are going to use the network storage here. It can only send the transactions in response to receiving a transaction here. And it does not have private keys anything. So instead that the logic of the smart contracts controls them here. So let me explain you the limitations of the current Ethereum accounts here. Okay. So these are the three very important limitations of the Ethereum accounts here. The first one is unrecoverable here. So what it means that here, it mandates users to manage their accounts seed phrases manually and private keys with no path to recovery if lost or compromised here, so that the accounts can be unrecoverable. And the stolen keys give thieves instant access to all the funds in an opportunity in an account here. The second one is that fixed transaction. So it is going to have a fixed transaction, means that it will have a restriction for specific applications as it requires users to pay gas in specific tokens and to approve every transaction individually. The third one is that not user friendly. So it is having a confusing and clunky user experience as new users cannot use the existing behaviors of these accounts and apply it to the blockchain focused websites and applications here. So let's move on to the smart contract accounts. So these are the very important benefits of account abstraction, which brings up to the Ethereum world here. Okay. So let me explain you one by one here. So enhanced security. So we are going to have enhanced security by having the multi-factor authentication authorization, which helps you to create tight, flexible, and enhanced account security. For example, we can have two-factor authentications here for the accounts. Next one is that permission controls. So users can create different account types with customized roles, permissions, and transactions limits here. And the next one is that easy account creation. So onboarding can now be very easy, as similar as to the other online services by just using your email or social accounts here. And next one is that account recovery. So users can set up social recovery accounts by just reducing reliance on seed phrases or private keys. If keys are lost or forgotten, the account can also be locked from another authorized device so that it protecting the user's assets here if the keys are lost. So next one is that sponsored gas fees. Yeah. So users can pay someone else gas or have someone else pay yours gas fees here for the transactions. And it provides you more opportunities for dApps, wallets, and services can sponsor gas fees for users here. And the last one is that bundle transactions. So transactions can now be bundled together to save on gas fees here. So let's move on to the next slide. So these are the four proposals to achieve the implementation of the account abstractions here. Okay. So out of these four proposals, the last two are currently not in active state. Okay. So let me explain you one by one here. So EIP-4337, it implements the account abstraction without changing the Ethereum protocol. Instead of modifying the consensus layer to support smart contract wallets, a new system is added separately to the standard transaction. The second one is that EIP-2771. It implements the account abstraction by using a meta transactions here. It allows third parties to pay for a user's gas cost without changing the Ethereum protocol. And the third one is that EIP-2938. It changes the Ethereum protocol to support account abstraction. And the last one is that EIP-3074. It upgrades the externally owned accounts for account abstraction implementation. Out of these proposals, EIP-4337 is a mature proposal and gives you a promising and possible way of achieving the implementation of account abstraction here. So let me explain you that EIP 4337 introduction part. So let's move on to the next slide. So what ERC 4337 proposal gives you here? Okay. So it is an account abstraction proposal which completely avoids the need for consensus layer protocol changes. Instead of adding a new protocol features and changing the bottom layer transaction type, this proposal introduces a higher layer pseudo transaction object. I would like to illustrate this point by showing you the architecture of the ERC-4337. As you can see, it introduces another higher layer transaction by not changing the underlying the network protocol here. Okay. So you can see that we have the user operations memory pool where it collects the user operations and sends to the bundler for bundling the transaction. And finally, it takes you to the Ethereum block for processing the transactions here. So let me elaborate furthermore on each of these components and technical details of it. Let's move on to the next slide. So these are the five key major components under the ERC-4337 standard here. As you can see in the diagram, so we have the user operations, bundlers, entry point, contract account, aggregators, and paymasters here. Out of these major components, so aggregators and paymaster are optional ones. And you can also see that the stages here. Okay. So it first comes to the user operations and goes to the bundler, and then it goes to the entry point, and finally it reaches to the contract account here. So let me elaborate further on each of these components and the details about it. So the first one is user operations here. So what is an user operations? So it is a similar like transactions, okay, but it has a pseudo transaction object used to execute transactions with contract accounts, and these are created by DApp here. So as I said that it is very similar to the transaction, it has that signatures, senders, address, max fee for gas, and max priority fee for gas. We have it here. And next one is that bundlers. This is a node that bundles multiple user operations together and sends that bundle to the entry point contract for executions here. And the third one is that entry point contract. It is a singleton contract that verifies and executes the bundles of user operations sent to it. And the fourth one is the account contract here. So it is basically a smart contract wallet of a user here. So this is the place where we verify a user signature and process the transaction on the Ethereum side. The next one is the aggregators. As I said, it is an optional. Okay, so it utilizes a helper smart contract to a bunch of user operation signatures and turns them into one signature here. And the last one is the paymasters, and this is also an optional. It can sponsor gas fees for account contracts or allow their owners to pay for those fees with ERC-20 tokens instead of ETH. Let's move on to the next slides. So here I'm going to represent the internal flow of every transactions of the higher layer system. As you can see that the core components of ERC-4337 in the left side diagram, okay, this illustrates the different stages of the ERC-4337 core components here. So let me take you through each of the stages and explain you further more on that. So the first stage involves that user sends the transaction in a form of user operations, which is otherwise called as a higher layer pseudo transaction objects. So every user operations will have a user operations object and with a paymaster optional here. So every user operation goes to the alternative memory pool. It is a unlike a public transaction pool, okay, where it processes that all of the user operations together here. So then in the stage 2, you can see that the bundler bundles all of the user operations and takes to the entry point contract here, sends to the all of the users operations to the entry point contract. So the bundler acts as the from address when getting user operations on chain. So they can order transactions and also include the own transactions to maximize their value capture here. And the third stage involves entry point contract here. So this is the very important place where it validates the each of the user operations and finally process the transaction on the smart contract wallet side. So the entry point contract is a singleton contract and verifies and executes the bundles here. So it first performs a sanity checks, like each of the user operations are real and valid to process on the on-chain transactions here. As you can see that in the left side of the diagram, so it does that validate user operations and executes the user operations and finally it reaches to the smart contract wallet. And it has an optional for the stage 4 here. So as you can see that the stage 4 involves that validation and executions here. So paymaster optional, it's the optional field. So whenever there is a paymaster, it will process the paymasters here. So the right side diagram illustrates the entry point contract sequences here in detail here. Let me explain you here. So when the user operation, each of the user operation reaches to the entry point contract, it first goes to the aggregator loop. If there is aggregator, it goes to the aggregator and where it bundles all of the user operation signatures and convert into the one user signature here, and then comes back to the entry point contract for validating the signature here, and then it goes to the verification loop. So the entry point contract creates a contract account if it doesn't exist here, and then it starts to validate the user operations. If there is no paymaster involved, it verifies the contract account has the sufficient deposit in the entry point to pay for the gas here, and then it validates the user operation. And if there is a paymaster involved, then it verifies the paymaster has sufficient balance in the entry point to pay for the gas here, and then validates the user operation, and then finally it takes to the execution loop here. So it calls the contract account with processed call data, and publish the transactions here. Then it finishes the transactions on the Ethereum side here. These are the references where you can find more detail about ERC-4337 and the implementations and the account abstractions, concept roadmaps, and everything here. Thank you for your attention. Now I'm happy to answer any questions you might have here.
Thank you, Mr. Ravikumar, for this great session. That was really nice. Uh, Friends, I would like to invite you to leave comments and questions on the chat, and our speaker will be delighted to read them and respond to them. Thank you once again for the session. I hope you all enjoyed it. And we hope to see you again, Mr. Ravi Kumar, again in future editions. Thanks for your time. And the next session will be starting in a few minutes. So remember to return to the official website. Thank
Thank
you.
you.